6.2 definite integrals, worked out problems. So this is just the transferring the limit to the integral, which is kind of pointless, but what are you going to do? So this equals integral from -7 to 5. It's there. And we change the summation to an integral sign. We change the c of k to x squared minus 3x. And then we change this to dx. That's it. Same thing over here. Integral 2 to 3. 1 over 1 minus x. Do I need the parentheses? In this case, no. I make it a habit of putting them in more often than not. Here I won't. But yeah, they're pretty handy. Equals integral 0 to 1. And the integral of pi to pi sine cubed x dx. And then it says to evaluate the integral. So we can use an antiderivative, but we're going to do this by graphing. So it's from 3 to 7. And goes down here to -20. That's the function. So -20 times 7 minus 3. Negative because we are below the x-axis. Off we go. -1 to -4, pi over 2. Equals above the x-axis, pi over 2, -1 minus -4. I honestly don't care how you do this as long as you know that we're looking at something positive. So that is 3 pi over 2. You can always check this with your calculator if you want. How do I do that? I'll do the first one just to be thorough. Math 8. Math 9. Integral from 3 to 7. -20. Respect to x. Notice they do put parentheses in on theirs. -80. So you can check it. Never a bad idea. Just graph the integrand, and the area is to evaluate the integral. One, two, three, four. 1, 2. So this graphs here. But we only want it from 1/2 to 3/2. Should have made this a little bigger, but that's okay. 3/2. So So this is 1/2, comma 3. This is 3/2, comma 1. So this is a trapezoid. The base is 1 long. So the area equals 1/2 height 3 plus height 1 times base 1, which is 3/2 minus 1/2. 4/2, 2 times 1. 2. And over here, looks like a horrible square root, but I know this is a semicircle, -4 to 0. Plug in 0, square root of 16 is 4. 1, 2, 3, 4. Plug in -4, we get 0. And it arches down here. We're looking for this area here. And it's just a circle. Pi r, which is 4 squared, but it's 1/4 of a circle. So it's 4 pi. Notice if you did this with a calculator, you would not get 4 pi, you'd get 4 times 3.14, which is an example where a calculator can check your work, but can't really find the answer unless you're intelligent about it. I guess you could back check, but at any rate. Same thing, area, off we go. One minus absolute value of x means x, which is a v, upside down and start at 1. And we only want this area here. So that is simple triangle. 1/2, base of 2, height of 1. Now, this is a circle, but the 1 pops the circle up a bit. So when we plug in 0, we get 2. Plug in 1, we get 1. So it does this and then comes straight down. Does this and then comes straight down. And this is 1 and -1. So the area, 1/2 pi r squared, radius of 1. That's the top half, plus the rectangle, 2 times 1 high. Pi over 2 plus 2. Off we go. Theta is just a straight line. Going from pi to 2 pi, I should have left myself a little more space on the right side. Up it goes from there. Trapezoid, 1/2 base 1, which is pi high and 2 high, pi plus 2 pi, times the distance here, which is just pi, 2 pi minus pi, equals 3 pi times pi, 3 pi squared over 2. Here's same exact problem. From root 2 to 5 root 2. root 2, 5 root 2, one half height 5 root 2 plus root 2 times 5 root 2 minus root 2. I could have just written 4 root 2, but what are you going to do? 6 root 2 over 2 is 3 root 2 times 4 root 2 is 12 times 2, 24. And onwards, 4x. From 0 to b. So now we get variables in the answer, which is a really devilishly clever way for an evil math teacher to not allow you to use your calculator. Maybe I should do that. That's an idea. B, and this is going to be 4b. So area is going to be 1/2 the base times the height, 2b squared. Same exact problem, except slightly different x values. Some A and some B. And draw it a little steeper. This is going to be 3b. And this is going to be 3a. Hey, look at that, a trapezoid. 1/2 3b minus plus 3a height times b minus a. Now, a little algebra here. 3/2 b plus a to b minus a. 3/2 b squared minus a squared. No, you don't have to write it all out. But hey, we're studly math people. Why not? Same problem again. Two A. 1/2 2a plus a 2a minus a 3a times a. It's going to be 3/2. Didn't we just do this problem? 3/2 2a plus a squared. Right. So 2a plus a is 3a times a is 3a squared over 2. Fairly confident you will see these exact problems on a quiz. I don't think many people graph it, which is a shame, but what are you going to do? One half a plus root 3a. If we root 3a minus a. equals 1/2 root 3a plus a times root 3a minus a equals 1/2 3a squared minus a squared, which is 2a squared over 2a squared. That's not bad. It's a cool little piece of math there. Now, here's the problem. When it's area, everybody's good. When I suddenly say it's something else, integral is not always area. It could be anything that goes from a rate, gallons per minute, to gallons. Bucket, 0.4 liters per hour, 2 gallons, liters. All right. Really, really, really simple. Exact same thing, but people just get lost suddenly. Whoa, whoa, what just happened? Off we go. Gallons per minute, hour, so we got to convert it to minutes. Integral from 0 to 60, 25 dt, I guess, for t for time, equals 25 times 60 is 1,500 gallons. Water lost, 6 to 9 p.m. Liters per hour, hours, don't have to worry about it. 0.4 liters per hour, 6, 7. Integral from 6 to 7, 0.4, again with dt, equals 0.4 times 1. Another mistake in my answer key. Liters. Nobody's ever told me. Use an int. I wonder if I can do this without an int. That's a use substitution problem. I might be able to do it, but I'm not going to bother right now. So, just because we've been doing so much graphing, this looks something like this. 5, and this is a 4. So, hey, what's that area is what they're asking. So, zero to 5. X over x squared plus 4. 0.991. I like writing this out just for the practice. Notice no parentheses because that's kind of a standalone piece. So now we're going to use nint for this one too. Area enclosed, graph of this, graph of that. -2 to 2, and if you look at this, it does some weird stuff like that. Integral from -2 to 2, x squared e to the negative x dx equals I think it's easier to do it from scratch. Math 9, -2, 2. They give me parentheses every time because they're careful. Intent, you might want to do something similar. Second e -x with respect to x, 13.425. And finally, find the points of discontinuity. Use area to evaluate the integrand. So this is going to be nasty. We need graph. And we need a lot of space. INT on the calculator. 2 math INT x -3. You may have seen this with, what the heck was that? 2 math x -3. You may have seen this with double slashes or double brackets. I think it is not double slashes, double brackets. But yeah, we're not doing that. Zoom 6 and let's graph it. So it's all these little lines and there's a zillion of them. It's going to make my life completely miserable, but that's okay. I'm used to that. So -6 to 5, huh? Go down here to -18 apparently. -6 -3, -9. It's just -9. Wow, that is way down there. 18. We plug in 5, 4, 3, get 0. So we'll hit 0 here. 1, 2, 3. Yeah, okay. So we get this, and then this, and then this. I'm purposely just trying to wedge them in because I didn't really graph this perfectly, which really wasn't in the mood to do anyway. Cutting it close. Technically, that's a -18. And yeah, that one was way too low. Otherwise, I think I would have gotten there. So that's what it looks like for 0 to 5. Technically, there's another dot up here. So we need all of these areas. Notice how most of them are negative. I'm supposed to locate discontinuities. So yeah, let's do that at the bottom. Discontinuities at -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5 because of the dot up there. No dot down here. -6 is good, actually. Shocker. And then area equals, since they're all being multiplied by 1 long, it's just -18, -16. Two, and that equals -88. Math 9, -6. Very curious if this is going to work. I haven't checked it. I just put it in as y1 so I can cheat with respect to x. Wow, that's pretty cool. We're awesome. We're awesome. We are so very awesome. Sorry, I promised somebody I wouldn't sing anymore in my videos. Too bad. All right, so this one, it's at -2. Because if I plug in 0, no, that's not right. -3. Plug in 0, get 9 over -3. And then it's one of those things, if you factor it, you get a straight line. So it looks something like this from -5 to 6 out here. There is a hole at 3. About here, there should be a hole in the graph. Otherwise, we got lots of area going on here. It's just triangles. So discontinuity at 3. And then the area is 1/2. This is too long. How do I know that? I just do. Minus 1/2. This is 9 long and 9 high. Equals -77 over 2. Whew, that's what I call working for a living. Good luck. Happy mathing.